Hi students, now from this lecture we will start with a new chapter of Fogler Chemical Reaction Engineering, multiple reactions, right? This is chapter number 6 as per the book that I have, right? You can see as per your edition what chapter number is this. So guys, multiple reactions, this is very important chapter, right? Because after going through this chapter, you would be able to determine the design of chemical reactor and reaction conditions, right? That will lead to the formation of desired product, right? And you would be able to determine or have idea about those reaction conditions or reactor type, right? Or the design of reactor that will lead to that will help you to minimize the formation of undesired product, right? Because normally what happens when a chemical engineer is carrying out a reaction in a chemical plant, right, or in a chemical reactor, in addition to the reaction, right, that is giving you main product, desired product we call it as, right, there are some reactions that will start occurring themselves in parallel or in side that will lead to the formation of undesired product, right? And why we are worrying about these undesired products? The main reason is that this undesired product needs to be removed, right, or separated from the undesired product, from the desired product, right? And in order to remove this undesired product from the desired product, you need to invest money. It involves cost, right? Because you have to apply separation techniques that will involve cost, right? So chemical engineer has to design in such a way, right? The chemical reactor he has to design in such a way, and the reaction conditions he has to determine in such a way that will lead to the minimum formation of these undesired product, right? So that less cost is involved in later separation of this undesired product from the desired product, right? So before we go ahead with more detail into how to set up the reactor type and the reaction conditions for the formation of for the minimized formation of undesired product, right, is we should know what type of these side reactions are taking place in the chemical reactor, right? So there are reactions, side reactions like parallel reactions. Then you have series reaction, complex reaction, which is a combination. Complex reaction is a combination of parallel and series reaction. Then there are some independent reactions that occur in the cracking of petroleum, right? We'll just talk about first multiple reactions, right? So the first type of multiple reaction is your parallel reaction. Parallel reaction, we also call it as competing reaction. Right? Now what are these parallel reaction? In parallel reaction, reactant would be consumed via two different reaction pathways, or we say. What we mean by this is that a reactant, in addition to forming a desired product, it will also start forming an undesired product, right? For example, if A is your reactant, right, through one reaction it is forming desired product, through another reaction it is forming an undesired product, right? And later we need to remove or separate this undesired product from the desired product, right, using separation techniques, and this will involve cost, right? So economic success of your chemical plant, right, will depend on the reactor design, right, such that you have minimum formation of these undesired products, and you have to involve less in separation techniques, right? This you have to keep in mind. So example, there is an industrial reaction, oxidation of ethylene, right, where you have a parallel reaction going on. We know that ethylene is an organic compound, so on oxidation it will give you carbon dioxide and water, right? But in parallel there is a reaction going on that will lead to the formation of ethylene oxide, right? Ethylene oxide, which is an undesired product, and later will need separation, right? So you have ethylene, oxidation of ethylene will form through one reaction, it will form carbon dioxide and water, right? These are your desired products. Through another reaction, it will form CH2, CH2, right? Ethylene oxide. Ethylene oxide is this is your undesired product. Undesired product, right? Now you have to later use separation techniques to remove ethylene oxide, right? So you have to, chemical engineer has to design in such a way that it will lead to the minimum formation of ethylene oxide and maximum formation of carbon dioxide and water, right? Because this reactant ethylene is getting utilized, right, in the formation of undesired product which is not required actually, right? So you have to set up the reaction conditions and the reactor type such that you have minimum formation of ethylene oxide and maximum formation of carbon dioxide and water, right? Now you have another reaction which is your, we call these as your series reaction, right? Series reactions going on in chemical reactor, right? We also call these as consecutive reactions. These are also called as consecutive reactions, right? Now let's understand what this is. If suppose you have a reactant A, it's forming product B, right? Now this B product will further react with the reactant to give you product C, right? So here basically you need to stop this reaction at a certain stage, right? We'll take example and that will help you to understand it. Actually this is, we call it as intermediate compound, right? And this intermediate compound will react with reactant, right, to give you another product. Now this will again react with the reactant to give you, say, D, right? Now you have to stop this, you have to design this reaction in such a way that it stops at the formation of desired product, right? Let's take an example of this type of reaction. There is an industrial reaction of ammonia with ethylene oxide, right? This is your ethylene oxide reaction of ammonia with it. Now look, it will form HO, CH2, CH2, NH2, right? Now this, right, this product will react with ethylene oxide again, right, to form HO, CH2, CH2 whole twice NH, right? And now this product will again react with ethylene oxide to give you HO, CH2, CH2 whole thrice, this is your NH, I'm sorry, N, right? So this is your mono, di and triethanol amine, right? This is your monoethanol amine, diethanol amine, right? And this is your triethanol amine, right? Now this reaction, when we do this reaction carry out this industrial reaction, mainly the product required is this diethanol amine. This is the desired product, right? So you have to carry out this reaction in such a way that reaction stops at this stage. This will not take place, right? Or minimize the formation of monoethanol amine, right? So basically these are your series reaction. These reactions are occurring in series. It is forming monoethanolamine, then diethanolamine, then triethanolamine, right? So here the required product is the desired product is your diethanolamine, right? So you have to carry out this reaction in such a way that this diethanolamine will not further react with ethylene oxide to give you triethanolamine, right? This is the example of your series reaction. Right, now you have complex reactions, right? Third type of reaction is your complex reaction. Complex reaction is basically the combination of parallel and series reaction, right? Combination of parallel and series reactions, right? It gives you a complex reaction, right? Now suppose you have two reactants, right? Suppose A plus B gives you C plus D. Now A plus C will again react to give you an undesired product, right? Say E, it gives you E, right? So you can see here reactant is getting consumed in the formation in this reaction and in this reaction, right? Like parallel reaction, and this product is reacting with this reactant to give you product E, right? Like in series reaction. So it is a kind of combination of your series reaction and parallel reaction, right? Let's take an example of an industrial reaction. The example is the formation of butadiene from ethanol, right? Formation of butadiene from ethanol, C2H5OH, right? This is your ethanol. Now just see what parallel and series reactions are taking place, right? Ethanol will form ethylene and water in one reaction, right? In one reaction it is forming ethylene and water. Now in another reaction it will form acetaldehyde and hydrogen, right? Now these two will react, right, to give you butadiene, right? Ethylene plus acetaldehyde will react to give you butadiene, C4H6, right? I hope this is clear. C4H6 plus water, right? I hope this is clear. Complex reaction, you can see this reactant is getting consumed in this reaction and in this reaction, right? Now like series reaction, the products are reacting to give you this and to give you this desired product. This is your desired product, right? So these are reactions that are occurring, right, in parallel or in series, right? And this is your desired product. So this reaction is basically giving you desired product, right? Now there are some reactions which we call as independent reactions. Independent reactions, in independent reaction what happens is the products that get formed, they will not react with reactants or among themselves, right, to form different products. These are independent reactions, right? For example, independent reactions. Independent reactions. For example, if A is reacting to give you B plus C, D reacts to give you E plus F. These two are independent reactions, right? And they are giving you products. These products will not react among themselves or with the reactants to give you different products, right? Or basically, in independent reactions, the products and reactants will not react among themselves, right? This is all. The example of this is cracking of crude oil, right? Example of this is your cracking of crude oil. Cracking of crude oil, right? To form cracking of crude oil will form gasoline, right? This is important for chemical engineers. We will do this cracking of oil sometime later in detail, right? So let's see some examples that takes some reactions that take place in cracking of crude oil. C15H32, right? This is a hydrocarbon in your crude oil which will react to give you C12H22 plus C3H6, right? This is one of the independent reaction that is going on. The other is this hydrocarbon C8H18 will also react to give you, it will react to give you C6H14 plus C2H4. These two are independent reactions, right? Now products of these two reactions will not react with reactants, right? Or products will not react among themselves, right? To give you different set of reactions. So these are your independent reactions, right? I hope all this is clear, right? So these are 4 types of reactions, right? Parallel, series, complex and independent reactions that occur in chemical reactor, right? In addition to, basically in these types of reactions, what we are trying to explain? We are trying to explain that in addition to main reaction, right, or in addition to a reaction that will give you your desired product, there are some reactions that are giving you undesired products also, right? And the aim of chemical engineer is to minimize the formation of undesired product, right, by adjusting the reaction conditions and the design of chemical reactor, right? This is the main aim of chemical engineer, right? And this is what we would be studying in this chapter, right? So one more thing that we need to study here is, you have, suppose this is a reactor, suppose this is the reactant, it is giving you a desired product and an undesired product, right? Now how can you adjust the reactor, right, or the reaction conditions that it will lead to the minimum formation of this undesired product, right? Now there are 2 things. When a chemical engineer will start designing, he has 2 things in front of him. First is, he use a costly reactor, because as you keep increasing the cost of the reactor, the formation of this undesired product will go down, right? Or, so here in this case, cost would be invested in the reactor type, right? If you take costly reactor, you will have less undesired product. The other thing is, right, that you have undesired product, you take low cost reactor, right? You take low cost reactor where you will get undesired product, right? Now later, if you take low cost reactor, later you have to invest in separation technique, because finally you have to separate out this undesired product from the desired product, right? So chemical engineer have to look into these 2 things, right, which will lead to more cost, right, that can save some money, right, from where he can show some benefit to the company, right? So here you have 2 things. Either you take costly reactor, right? In costly reactor you have less undesired product, or you take cheap reactor, right, that will have more undesired product, and here you have less undesired product, right? So in the second case, in cheap reactor, you have to invest. You have to invest or invest in separation technique. Right? You have to invest in separation technique. So these two things, investment in separation technique and the cost of reactor. Here you have to see where you can save more, right? This is how you can, these two things you have to consider while designing a chemical reactor in order to carry out, in order to carry out a chemical reaction, right? I hope this is clear. Now in the next lecture we will look into what is selectivity, right, and what is reaction yield. So through selectivity we can minimize the formation of this undesired product, right? Thanks.